Question 1. Out of 3 persons, A, B, C, 2 persons are selected at a time. Find the number of possible selections. Correct answer is option B. 3 distinct persons A, B, and C are given, and 2 persons are to be selected. Now let us consider selection. Selection refers to choosing a subset of elements from a given set without considering their order. In this case, only selection is involved and arrangement is not required. Let us examine combination. Combination is defined as the selection of objects where the order of selection does not affect the outcome. Order is not important, so AB and BA are considered the same selection. We now discuss order. Order means the sequence of arrangement, and in combinations different sequences of the same elements are treated as identical. All possible selections are AB, BC, and AC. We now analyze selections. Selections represent distinct groups formed without considering arrangement. The total number of selections can be calculated using the combination formula to the power NCR equals N divided by R, NR. Consider combination formula. The combination formula gives the number of ways to choose R objects from N distinct objects without considering order. Substituting N equals 3 and R equals 2, we get to the power 3 colon 2 equals 3. Divided by 2, 3 minus 2 equals 3. Thus, the total number of possible selections is 3. Question 2. Out of 3 persons, A, B, C, 2 persons are selected at a time and arranged. Find the number of possible arrangements. Correct answer is 3 distinct persons A, B, and C are given, and 2 persons are to be selected and arranged. Now let us consider selection. Selection refers to the process of choosing a subset of elements from a given set without considering order at this stage. In this problem, both selection and arrangement are involved. Let us examine permutation. Permutation is defined as the arrangement of selected objects in a specific order, where different orders are counted separately. Order is important, so AB and BA are considered different arrangements. We now discuss order. Order means the sequence in which elements are arranged, and a change in sequence leads to a different permutation. All possible arrangements are AB, BA, BC, CB, AC, and CA. We now analyze arrangements. Arrangements represent all distinct ordered outcomes obtained from the given elements. The total number of arrangements can be calculated using permutation formula to the power NPR equals N divided by NR. Consider permutation formula. The permutation formula gives the number of ways to arrange R objects selected from N distinct objects. Substituting N equals 3 and R equals 2, we get to the power 3p2 equals 3, divided by 3 minus 2, equals 6. Thus, the total number of possible arrangements is 6. Question 3. How many words, with or without meaning, can be formed using all the letters of the word cat, using each letter exactly once? Correct answer is option B. Total letters in the word cat equals 3. Each letter is used exactly once, and repetition is not allowed. All letters are distinct, C, A, T. Order is important in forming words. Now let us consider order importance. Cat not equal to CTA not using permutation formula. Let us examine permutation formula. To the power NPR equals N. Using single slot method. We now discuss slot method. First position equals 3 choice. Total number of words formed equals 6. Question 4. How many words, with or without meaning, can be formed using the letters of the word cat, if repetition of letters is allowed? Correct answer is option. Total letters available equals 3, C, A, T. Number of positions to fill equals 3. Repetition is allowed, so each letter can be used multiple times. Using multiplication principle. Now let us consider fundamental principle of counting. If an event can occur in m ways and another in n ways, total ways equals m times n. Each position can be filled in 3 ways. Let us examine slot method. First position equals 3 choices. Total number of words equals 3 times 3 times 3 equals 27. Thus, total number of words formed equals 27. Question 5. How many 5-letter words, with or without meaning, can be formed using 5 distinct letters, when I, repetition is not allowed and 2, repetition is allowed? Correct answer is option B. Total distinct letters equals 5. Case, I, repetition is not allowed. Using permutation principle. Now let us consider permutation. Number of arrangements equals 5 times 4. Case, 2 repetition is allowed. Using multiplication principle. Let us examine fundamental principle of counting. Each position can be filled in 5 ways. Thus, required answers are 120, without repetition, and 3125, with repetition. Question 6. How many different 4-letter words can be formed from the letters of the word logarithms using each letter exactly once? Correct answer is option A. Total letters in the word logarithms equals 10. All letters are distinct and each letter is used at most once. We need to form 4-letter words without repetition. Using permutation principle. Now let us consider permutation. Number of ways equals to the power. Thus, total number of different 4-letter words equals 5040. Question 7. A painter has to paint a 4-digit number on a number plate using the digits 1 2 3 4 5 6 7 8, 9. How many such numbers can be formed when I, repetition is not allowed and 2. Repetition is allowed. Correct answer is option A. Total available digits equals 9, 1 to 9. Number of digits to be placed equals 4. Case I. Repetition is not allowed. Using permutation principle. Now let us consider permutation. Number of ways equals 9. Case 2. Repetition is allowed. Using multiplication principle. Let us examine fundamental principle of counting. Each position can be filled in 9 ways. Thus, required numbers are 3024, without repetition, and 6561, with repetition. Question 8. A painter has to paint a 4-digit number on a number plate using the digits 1, 2, 3, 4, 5, 6, 7, 8, 9. How many such numbers can be formed when repetition of digits is not allowed? Correct answer is option A. Total available digits equals 9, 1 to 9. Number of digits to be placed equals 4. Repetition is not allowed, so each digit is used only once. Using multiplication principle. Now let us consider first position. Equals 9 choices. Let us examine second position. Equals 8 choices. We now discuss third position. Equals 7 choices. We now analyze fourth position. Equals 6. Total number of 4-digit numbers equals 9 times 8 times 7 times 6. Calculation. Thus, total number of such numbers equals 3024. Question 9. In how many different ways can the letters of the word apple be arranged? Correct answer is option B. Total letters in the word apple equals 5. The letter P is repeated 2 times, while O, L, and E are distinct. When repetition of identical letters occurs, total arrangements are reduced. Using permutation formula with repetition. Now let us consider permutation with repetition. Number of arrangements equals n. Calculation, 5. Equals 5 times 4 times 3 times 2 times 1 equals 120. 120 divided by 2 equals 60. Thus, total number of different arrangements equals 60. Question 10. Number of ways of selecting 2 balls from 5 similar balls is. Correct answer is option. Total balls equals 5 and all balls are similar, identical. We need to select 2 balls from given balls. Since balls are similar, they are indistinguishable. Now let us consider identical objects. Identical objects are those which cannot be distinguished from each other, so different selections appear the same. In this case, selection does not depend on which specific balls are chosen. Let us examine selection. Selection refers to choosing objects, and for identical objects, all choices are equivalent. All selections of 2 balls will look identical. Thus, only one unique selection is possible. Total number of ways equals 1. Question 11. The number of ways in which 5 boys and 4 girls sit around a table so that all the boys sit together is. Correct answer is option. Total persons equals 5 boys plus 4 girls equals 9. All boys must sit together, so treat 5 boys as a single group. Now total units equals 1 group, boys, plus 4 girls equals 5 units. Since arrangement is around a circular table. Now let us consider circular permutation. Number of circular arrangements of n objects equals n-1. Arrange boys within the group. Let us examine permutation within group. 5 boys can be arranged among themselves in 5. Total arrangements equals 4 times 5. Thus, total number of ways equals 4, 5. Question 12. If to the power 2n3p equals 100 to the power np2, then the value of n is. Correct answer is option. Given, to the power 2n3p equals 100 to the power np2. Using permutation formula. To the power npr equals n. Divided by n minus r. Expand both sides. To the power 2n3p equals 2n, 2n minus 1, 2n minus 2. To the power np2 equals n, n minus 1. Substitute into equation. 2n, 2n minus 1, 2n minus 2, equals 100 times n, n minus 1. Simplify the expression. 2n, 2n minus 1, 2, n minus 1, equals 100 n, n minus 1. 4n, 2n minus 1, n minus 1, equals 100 n, n minus 1. Cancel common terms n, n minus 1. 4, 2n minus 1, equals 100. Solve for n. 2n minus 1 equals 25. 2n equals 26. n equals 13. Thus, the value of n equals 13. Question 13. Find n if n plus 2 equals 60 times n minus 1. Correct answer is option A. Given, n plus 2 equals 60 times n minus 1. Expand n plus 2 as n plus 2, n plus 1, n, n minus 1. Substitute into equation n plus 2, n plus 1, n, n minus 1 equals 60, n minus 1. Cancel common term, n minus 1. Obtain, n plus 2, n plus 1, n equals 60. After simplification, n to the power 3 plus 3n to the power 2 plus 2n equals 60. Check integer values of n, 3. For n equals 3 tends to 3 to the power 3 plus 3 times 3 to the power 2 plus 2 times 3 equals 27 plus 27 plus 6 equals 60. n equals 3 satisfies the equation. Thus, the value of n equals 3. Question 14. Evaluate, C, n, r, plus 2 column, n, r minus 1, plus c, n, r minus 2. Correct answer is option B. Given expression, c, n, r, plus 2 column, n, r minus 1, plus c, n, r minus 2. Use Pascal's identity. Now let us consider Pascal identity. C, N, R, plus C. Group terms. C, N, R, plus C, N, R minus 1, plus C, N, R minus 1, plus C, N, R minus 2. Apply identity to each group. First group equals C, N plus 1, R. Second group equals C, N plus 1, R minus 1. Add results. C, N plus 1, R, plus C, N plus 1, R minus 1, equals C, N plus 2, R. Thus, the required result is C, N plus 2, R. Question 15. If C, 20, N plus 2, equals C, 20, N minus 2, then N is equal to. Correct answer is op. Given, C, 20, N plus 2, equals C, 20, N minus 2. Use property of combinations. Now let us consider combination property. C, N, R. So, either. Case 1, R equals R tends to N plus 2 equals N minus 2, not possible. Case 2, R plus R equals 20, complementary values. 2N equals 20. N equals 10. Thus, the value of N equals 10. Question 16. How many 4-digit natural numbers are there such that all of the digits are odd? Correct answer is option A. Odd digits equals 1, 3, 5, 7, 9 tends to total 5 digits. We need to form a 4-digit number. Repetition is allowed. Now let us consider repetition. When repetition is allowed, the same digit can be used in multiple positions. Each position can be filled independently. Let us examine multiplication principle. Total ways equals product of number of choices for each position. Thousands equals 5, hundreds equals 5, tens equals 5, units equals 5. Total number of ways equals 5 times 5 times 5 times 5 equals 625. Thus, total number of such numbers equals 625. Question 17. If C, 15, 8, plus C, 15, 7, equals C, N, R, then the values of N and R are. Correct answer is option B. Given, C, 15, 8, plus C, 15, 7. Use Pascal identity. Now let us consider Pascal identity. C, N, R, plus C. Apply identity. C, 15, 8, plus C, 15, 7, equals C, 16, 8. Compare with C, N, R. N equals 16 and R equals 8. Thus, the values are 16 and 8. Question 18. If binom 158 plus binom 157 equals binom A, then the values of N and R are. Correct answer is option B. Combination represents the number of ways of selecting R objects from N objects without considering order. Now let us consider combination. According to Nzet, binom A equals N divided by R, NR, which gives the number of possible selections. Pascal identity relates two consecutive combinations of the same N. Let us examine Pascal identity. The identity is binom r plus binom r minus 1 equals binom plus 1r, which is a standard result in binomial expansion. The given expression binom 158 plus binom 157 follows this identity. Applying the identity gives binom 158 plus binom 157 equals binom 168. Comparing with binom r, we obtain n equals 16 and r equals 8. Thus, the correct answer is 16 and 8. Question 19. What is the number of diagonals of a heptagon? Correct answer is option A. Polygon is a closed plane figure formed by joining line segments, where a heptagon has 7 sides. Now let us consider polygon. According to Quantitative, a polygon is a simple closed figure made up of only line segments, and a heptagon specifically has n equals 7 sides. Diagonal is a line segment joining two non-adjacent vertices of a polygon. Let us examine diagonal. As defined in geometry, a diagonal connects vertices that are not next to each other in a polygon. The number of diagonals in an n-sided polygon is given by the formula n-3, divided by 2. For a heptagon, n equals 7, so number of diagonals equals 7, 7 minus 3, divided by 2 equals 7 times 4 divided by 2 equals 14. Thus, the number of diagonals in a heptagon is 14. Question 20. The value of to the power 20 column 1 plus 2 times to the power 20 column 2 plus 3 times to the power 20 column 3 plus ldts plus 20 times to the power 20 column 20 is. Correct answer is option B. Binomial theorem gives the expansion of 1 plus x to the power n in terms of combinations. Now let us consider binomial theorem. According to Quantitative, 1 plus x to the power n equals sum underscore r equals 0 to the power n binom r x to the power r, which represents expansion using binomial. Differentiation is used to generate coefficients multiplied by r in binomial expansions. Let us examine differentiation. Differentiating 1 plus x to the power n gives n 1 plus x to the power n minus 1 equals sum underscore. Multiplying both sides by x gives n x 1 plus x to the power n minus 1 equals sum underscore r equals 1 to the power n r binom r x to the power r. Substituting x equals 1 gives sum underscore r equals 1 to the power n r binom r equals n dot 2 to the power n minus 1. For n equals 20, sum underscore r equals 1 to the power 20 r binom 20 r equals 20 dot 2 to the power 19. Thus, the required value is 20 times 2 to the power 19.